Good evening, dear students. Today's session is dedicated for discussing the important formulas of centroids. So, let me just make you go through the importance of this topic. So, the formulas what we use in centroids is going to help us further in the subjects like strength of materials, fluid mechanics, machine design, and theory of machines. Now, let me be very specific over here. In strength of material, especially when you are doing shear force and bending moment analysis, and the second topic is deflection of beam. This is where the importance of these concepts will be recalled multiple number of times. And coming to next subject, that is fluid mechanics. In the fluid mechanics, we have a topic called hydrostatic forces or center of pressure. There is a topic. So this topic once again will be making use of the concepts from the centroid. Now, let us try to understand that how is it really difficult for us to memorize these formulae, or is it easier? And the last subject that is I have included is theory of machines and machine design. In this subject, when we talk about the effect of dynamic actions, it could be in the form of a gyroscope, it could be in the form of a centrifugal force. All these effects will be marked by considering the effect of centroid. Now let's see the formulas. So very first one we have got is rectangle, and that's known to many of you. Area is breadth into height, and x and y coordinate will be at a distance of b by 2 from the origin, and y coordinate will be at a distance of h by 2. So this will be b by 2 and h by 2. This is for rectangle. Now, if the same rectangle, the vertex of the rectangle was coinciding with the origin over here. So if that is the case, then centroidal coordinates are directly expressed in terms of dimensions of rectangle, that's straight away b by 2 and h by 2. Now if the same rectangle vertex is at a distance of x from the origin in horizontal direction and y from the origin in vertical direction. So for this case, if you want to calculate the centroids with respect to vertex, if you want to mark, then it would be straight away b by 2 and d by h by 2. b by 2 and h by 2. But now, if you consider origin, then many of the students are likely to miss out, especially this distance x and y. So one has to be very careful when you are measuring the centroid from which point it is been marked. Is it the vertex or is it the origin? That should be very clear to you. Most of the time, the students miss out these distances. Instead, they express centroid as b by 2 and h by 2. And that should not happen. So for second case, centroid in x direction will be x distance from the origin plus b by 2. And for y, it will be y distance from the x-axis plus h by 2 it would be. So this is how you can express the centroid if the vertex is not coincident with the origin. Now moving to next figure, that is triangle. Area of the triangle is half base into height. Now here in the triangle, there are two things you have to remember. So now here is the centroid expected to be. If the right angle edge of the triangle is coincident with the origin, then in that case, the location of centroid will be at a distance of, let's say this is b and this is h. So centroid will be at a distance of b by 3, that is 1/3 of base, and for height it would be 1/3 of h if you are going from the right angle edge. And this portion or this vertex of triangle is called as apex. If you are going from the apex side, then it will be marked as 2/3 of base, and from the vertical apex, if you are going, then it will be marked as 2/3 of height. Now the same way, if I want to take a case, let's say this is a triangle, and this triangle is kept at some distance. Its apex is not coinciding with the origin. If that is the case, then you should be considering the distance x. And same way, if the base of triangle is not on the x-axis, it's, let's say, somewhere over here, then the distance from the x-axis also needs to be taken into consideration. And now here, if you want to mark the centroidal coordinates, then the centroidal coordinates from apex, it will be 2/3 of base, and from the origin it would be x plus 2/3 of base. And same way for y, this would be x bar, and y bar will be, the y distance should be added first of all, and we are finding that the centroid is nearby to the base. So from the right angle edge, and if we are heading upwards from the right angle edge, if we are heading upwards, then it should be taken as 1/3 of the dimension. That's 1/3 of the height. So y plus h by 3. So this is very crucial. You have to consider the distances from the origin in case if any of the triangle or rectangle vertex is not coincident with the origin. So many of the time the student miss out adding these coordinates, and you find the same thing happening even in the subjects like fluid mechanics. That is when we study about center of pressure, and the variation of pressure is going to be triangular. And for writing a mathematical equation for the pressure variation, we need to make use of these centroidal coordinates. So please don't forget this. And this was a simple one. So x coordinate for the triangle, as if you are going from the right angle h, it would be h by 3. Sorry, it would be b by 3. This is from right angle h. And along y direction, it would be h by 3. And if you consider apex, then it would be 2/3 of base and 2/3 of height. This is called as apex. Okay. So next, if we have scalene triangle wherein no two sides are equal, if that is the case, this was the right angle triangle. So if that is the case, then how is that we mark the centroids? So now we have to split this into two triangles by drawing a vertical. And let's say this side can be obtained by using trigonometric ratio. Let's call it as A and let's call this as B. So now this would be area number 1 and area number 2. And you are finding over here that the scalene triangle is been split into two right angles, but they are of different sizes, and height h is common to both the right angle triangle. So if you are asking me for figure number 1 and that to the centroid, it would be 2/3 of base. So x1 will come out as 2/3 of A. And same way for area number 1, the y coordinate will be common to both, and that will be for area 1 as well as 2, y coordinate will be straight away h by 3. And if you want to calculate for area number 2, then area number 2 is at a distance of A from the origin that needs to be added. Along with that, you are going in the direction, or you are going to face the first point is right angle h. If we are facing the right angle h, then in that case, from the right angle h, the centroid will be located at a distance of b by 3. So we are finding the reflection of the point what we have discussed just before this. So please, dear friends, go through these formulas and try to practice it, so that when these formulas are called up in the extended concepts, you should not be struggling or giving much time to these, as you should be focusing more on the depth of the concepts. Now, these will become fundamentals for you when you go over there. So this was for the scalene triangle. If you consider isosceles triangle, in that case, isosceles triangle, let me just increase the size of this. So if that is the case, for isosceles triangle, centroid will be directly at b by 2 location because of the symmetry with respect to y-axis, and the centroid from the base will be at a distance of h by 3. So this is for isosceles triangle. Now moving to next element. Next element is quarter circle. So for quarter circle, area of quarter circle will be pi r square by 4. Let's say this is the radius r, it will be pi r square by 4. Now, once again, we have to recall the approach, the same approach what we have used in the right angle triangle. So, is the right angle vertex coincident with the origin in case of quarter circle? Yes, we are finding that. We are finding that. If that is the case, then x and y coordinates will be located at the same distance. In the triangle, we have written that as 1/3 of base and 1/3 of height. But now 1/3 will be replaced with 4r by 3 pi, 4r by 3 pi in the x direction as well as in the y direction. So you are finding totally a different number, that is 4 by 3 times, or 4 by 3 pi it is. This is the newly, or this is the constant or new constant that is being added. And same way, if you are approaching from the other end of the right angle vertex of quarter circle, that would be from the curvature side. So if that is the case, then the distance would be r minus 4r by 3 pi, because the total distance or base of quarter circle is r, and this distance, by using the first principle, we get it as 4r by 3 pi, and the left out dimension will be r minus 4r by 3 pi. Same way, even if we are going from the top, this dimension will be once again 4r by 3 pi. Now you can draw the quarter circle as you like and mark the x and y axis. And when you do the marking, let's say this is the centroid. Okay. So this is a rough sketch. Please don't mind about the drawing. So now here, this would be x coordinate, or I should be marking the distance from the x-axis and y-axis. Let me just, this would be from the x-axis, and this would be the x distance, and same way this would be y distance. Now let's write this distance as x and this distance as y, and here x bar can be written as x plus something. What is that something? I need to write. And y bar can be written as y plus something. So now you are finding that in case of y direction, the right angle edge will be faced. It's not the curvature side, it's the right angle edge. So the same coordinate, that is 4r by 3 pi, will be copied over here. But whereas in x, this distance, we have marked it as 4r by 3 pi. But since the measurement of centroid is done from the curvature side, so x bar will be equal to x plus r minus 4r by 3 pi. You have to learn this practice of writing and measuring the centroid from different points. Only then it would become easier for you. Next we have is quarter circle. So quarter circle even, sorry, semicircle, even in the semicircle, same results what we have obtained in quarter circles, those will be reflected without any doubt. So area of semicircle is pi r square by 2, and x coordinate will be straight away r, and y coordinate will be, since we are going from the diameter or the base of quarter circle, so that's where the right angle vertex of quarter circle can be located, and from there if we are going, then the distance would be 4r by 3 pi. So the same result is being reflected even in the semicircle. So once again, you should be understanding the position of semicircle from the origin, and then how far it is specific to x-axis and y-axis. Both the distances needs to be reflected when we are measuring the centroid. Now, next we have got is trapezoid. So trapezoid is combination of two triangles or a single triangle and a square as well. So if you try to split this into three elements, then the expression may become lengthier. So in order to avoid that, there is a simple trick for x-axis coordinate that if you remember, it will be enough. But for y coordinate, it's going to be a very complex and lengthy expression. So as of now, I want to avoid that. X coordinate or writing the x coordinate can be learnt without applying much efforts. Area of the trapezoid can be expressed as average of two sides into height. Let's say this is h. So this would be a plus b by 2 into h it will be. And now I will avoid writing the y coordinate. I prefer to write x coordinate. So x coordinate has to be written as a plus b by a plus b into just a minute. Let me just change the orientation of centroid, trapezoid. So let's say this is a trapezoid and its vertex is coincident with the origin. Let's say this dimension as a, and yeah, I need to change this, and let's say this dimension as b and this dimension as c. So area of trapezoid is average of two sides, that is b and c are the vertical sides, average of b plus c by 2 into base, that is a, and centroid in x direction can be written as First, I need to write it as B plus C by B plus C into A by 3, you write it. B plus C by B plus C into A by 3. A by 3 is the base of the trapezoid. Now, there has to be a smaller change that needs to be accommodated in the expression. So, the centroid of trapezoid is expected to be somewhere over here. So now, if I am going from the B side to mark the centroid, then I have to multiply with a number to the opposite side of B, that is C. So here, when I am going from the B side towards the centroid, the dimension C needs to be multiplied with a number 2. So I have written that as B plus C by B plus C. There is nothing wrong in that. But since I am heading from B side, so 2 should be multiplied with C. This is the shortcut by which you can by heart the formula for trapezoid. This is for X coordinate. For Y coordinate, the expression is lengthier. You can avoid it because reason is that the Y coordinate in many of the applications we are not using as such. Most of the time, or 95% of the cases, we will make use of the centroid in X direction, or this formula especially we will be making use. So Y coordinate can be avoided. Next is spandrel. So for spandrel, the equation is expressed as y is equal to kx power n. This is y is equal to kx power n. So now, for writing the area of spandrel, we can use the basics that has been learned in the triangle. In case of triangle, the equation would become right angle triangle. If we go back to the right angle triangle, if we refer to this equation could be expressed as y is equal to kx power 1. Kx power 1. But here the triangle has to be like this. Let me correct it. The triangle has to be like this. This line refers to y is equal to kx power 1. And same way, even in the next case, the equation, or I need to modify this. So I need to modify this. Let me just remove this out of here. Now the spandrel, this is exactly coincident with y is equal to kx power n. Okay. And here, if I go back to triangle, the triangle was supposed to be like this. This is the orientation how the triangle has to be. Only then the equation y is equal to kx power 1 will be valid. And the formula we have written that as 1 by 2 times of base into height. And for spandrel, what I'll do is I will write it as base into height. This would be base and this would be height. So I would write that as 1 by 1 plus 1. This is half base into height. And this is applicable for the triangle. But are we dealing with triangle? No, we are dealing with spandrel. So if that is the case, then there has to be some change that needs to be accommodated over here. So now instead of writing 1 plus 1, it becomes 1 by n plus 1. N could be any value, 2, 3, 4, whatever it is. So it would become 1 by 1 plus n into base into height. This would be area of the spandrel. This is n, dear students. Now, same way, if I go back to triangle, the centroid of triangle is taken from apex, or let's say this is the apex, and from apex if we try to measure, it is 2/3 of the base. So I want to utilize my learning and extend that learning in the spandrel. So now in the triangle we have written it as 2/3 of base. In spandrel, how do we write it? The x coordinate, I mean this is similar to apex of the triangle, but it is not exactly the triangle. So we have written that as 2/3 of base. 2 can be written as 1 plus 1 by 1 plus 2 into base. Okay. So now 1 will be replaced with n. It becomes n plus 1 by n plus 2 into base. This is how the change would be reflected. If you keep in place of n as 1, 2 or 3, and you can get the answers very easily. And now we are finding the base of the spandrel to be coincident with the x-axis. If that's the case, then once again make use or recall the results from the triangle. Then that if we are going from the right angle edge, then it has to be 1/3 of height. So 1/3 of height could be written as 1 by 1 plus 2 into height. So this one will be replaced with n. That's how you can write the centroidal coordinates. Let me just correct over here. This is not n plus 1 by n plus 1. This has to be y is equal to n plus 1 by 4n plus 2 into height if we are measuring. So that is not going to work in case of y coordinate, but for x coordinate this is going to be helpful. So thank you, dear students. Go through this formula thoroughly and by heart this formula for now. So next when you apply, it becomes easier for you in the extended concepts.